is about graphing polynomials. And of course, everything's a little bit different when you're doing online homework than when I'm just working with it here. This is one of the lessons where we put together several different skills that we've worked on in some previous lessons. We have talked about how to look at leading terms and determine if things are going up or down on the left and right in behavior. And the degrees also helps with that, because leading terms that have an even degree, their in behavior is going the same direction, and if it's an odd degree, it's going different directions. We know that when we plug in a 0 for x, and we find that functional value, we'll find the y-intercept. And we have solved equations by setting them equal to 0, and that essentially moves us into the zeros, which are x-intercepts. Now, we've looked at also multiplicities of zeros. Zeros with odd multiplicities cross the x-axis, while those with even multiplicities are tangent to the x-axis, which means they touch it without crossing. So it's kind of like they bounce and curve back the other direction. So besides these things, we're going to add just the concept of checking a few points between and beyond. Now, how many points should we check? There's no distinct thing. It kind of depends on how much information you have when you've looked through these other things. But what we're going to do is take this equation then, where it just says graph it. And I've got a little note here where we've got some of this stuff just kind of short-cutted. And we are going to look at how much information we can get from all of that as it is. First of all, when I look up here at this leading coefficient, what I see is that it's positive and that the power is odd. Positive means it is headed up on the right, and odd means the ends are going different directions. So just from looking at that leading coefficient, I know the ends do something like that. So that's what the end behavior is about. Now find the y-intercepts. We get the y-intercepts whenever we plug in 0 for x. So if you plug in 0 for x, these first three terms all become 0. So we're just left with -4. So my y-intercept is 0, -4. Then to find the zeros, we do that by setting the entire thing equal to 0. So I'm going to take 2x cubed plus x squared minus 8x minus 4 and set it equal to 0. This is going to factor, I believe, and there's factoring by grouping. And you may have learned another technique to do that. When I factor by grouping, I tend to draw what kind of looks like a tic-tac-toe at the beginning. And I put my terms inside those squares. And this just kind of helps me focus by looking at two terms at a time. So if I look at just the two terms here in this column, I can divide both of those by 2 and by x. If I look only at the second column, the only thing that divides into both of those is 1. Now I'm going to look at rows. Going across here, I can get x squared. And going across here, I can get -4. And the reason it's negative, if the very first thing in either a column or a row is negative, then you put a negative there. Always take out a negative if your lead term is negative. I can look at then this group and this group, and that's how this factors. So I have 2x plus 1, and then x squared minus 4. Now x squared minus 4 factors again. So I have 2x plus 1, x plus 2, x minus 2. Looking at the zeros of these, this one, what would make this particular parentheses equal 0 if x was -1/2? And I just do that for each one of them. So I have 3 different zeros, and they all have a multiplicity of 1, which means this graph is going to cross the x-axis in all 3 of these places. Okay, so now before I try to find additional values, I'm going to see what this tells me. Now, this is where it's going to get a little bit dicey about me trying to graph here where we know it's not really on a graph. You can see I can't really draw straight lines, but we're just kind of going to look at what this tells me. So let me, first of all, put some markings on here. It looks like the biggest number I've identified is this -4. So I'm just going to go out to 4 each direction. Oh, I'm sorry about the little drag line there. But I think if I try to erase it, it'll end up worse. Okay, so now I've got 4 marks each direction. So if you look at what we have so far, and let me go back and maybe we'll pick up red to get that. I know that my intercept here is 0, -4. That's right here. And I know I have X-intercepts, which are going to happen on this x-axis at -1/2, -2, and +2. Now let's add in this idea that we know that it's headed way down on the left and way up on the right. So coming from this point, it has to be headed down. And then coming from this point, it has to be headed up. And we know that it crosses at all of these. So what I don't know is how high up should it go? I almost do know how low it goes because I know it has to cross that intercept, and then it's going to probably go down a little bit further, but I don't know exactly. So if I wanted additional values, the additional values I would find are between these 2 points I know to find out how high it turns around. And again, this is going to be for me to sketch. I'm not a machine, so I'm just going to plug in the -1. And I'm going to plug that in up in here, and we'll see what it equals in just a second. And then I'm going to plug in +1, and that'll give me something in between these points so that I can see what's going on. So when I plug in a -1, what does this equation equal? Well, this would become -2 plus 1 is -1, plus 8 is +7, minus 4 is 3. So when I plugged in a -1, I got 3. So see, I have this other point here, which gives me a pretty strong idea of how high it goes. Not exact, but close. And then the other side, 2 plus 1 is 3, minus 8 is -5, minus 4 more is -9, which is going to go off my graph down. But what I know then is it's really still going quite a bit further down. And we will let that be that. So you can see that we get a strong shape of the graph from this information that we know. Now the whole world will be different when you're using your graphing calculator. I get that. But part of what you'll need to do is identify which one of your graphs that they're presenting you is correct. And the way you want to do that is figure out this information first, so that you're not just kind of looking at graphs that all look the same, but you can get in and say specifically, did they have the y-intercepts correct? Do they have the zeros correct? Is the end behavior correct? And then if you're still working, find another couple of points. We can also just kind of know something else about it. If we have a polynomial function, if you look at the degree, then the function has at most that many real zeros. And then if you take that degree and subtract 1, that means you have at most n-1 turning points. So here on this function, which is the same one we were looking at before, we have a 3rd degree polynomial. N is 3. So that means we have at most 3 real zeros. And at most 3 minus 1, which of course is 2, turning points. Now on our previous slide, that was the same thing. So let's go back and look at that and see about our 3 real zeros and 2 turning points. The 3 real zeros are right here on this x-axis, and then the turning points are these hills and valleys, you know, like maximums and minimums. So we had 2 turning points. So that works. So if you graph it, you should know that you're having this many. We're going to do this again. I don't have the steps written out, but this one is already factored for us. So one of the things that you want to do is, even if it's factored, you do need to know what the leading term is. So I'm going to take just the first term of each one of these and multiply it together. So we would have -1/2 times x times x squared, because see that squared right there, times x. So the leading term of this, if we multiply the entire thing back together, would be -1/2 x to the 4th. So now I can apply that leading term information. If it's negative, then I know it's headed down on the right. But if it's an even, I know it's going the same direction. So I don't know what all's happening in the middle right now, but I know this one is headed down on both sides of the end behavior. If I try to find f of 0, again, I don't want to multiply all this back together. I'm just going to put the zeros in for x. And it leaves this. So when I multiply that back together, I will have my y-intercept. Okay, so, oh, and there was a negative right here. -1/2 times -2 is +1. +1 times 1 squared is still 1. And 1 times -1 is -1. So I have my y-intercept at 0, -1. Now, I'm going to look at the zeros, and this one's already factored, so I'm looking up here to see what the 0 is for each one of these individuals. The very first 0 I get is for this x, and it is 2, and it has a multiplicity of 1. This x has a 0 at -1, but the multiplicity of that one is 2 because of this squared out here representing that there's 2 parentheses like that. And then my last one is a 0 at 1, and it's got a multiplicity of 1. So now we want to get that information kind of sketched out on a graph. First of all, the y-intercept is at 0, -1. The zeros occur at 2, -1, and +1. Now I know on the left-hand side and the right-hand side it's headed down. So from these outer points, it's definitely headed down both ways. Well, if it's headed down here on the left, then it's going up here. It had to turn around in order to hit this. So I don't know how high it went, but it had to have turned around to hit that point. And then it at -1, we have a multiplicity of 2. Oh, so at -1, it actually didn't cross there. It bounced off. That's what that multiplicity of 2 meant. So it's headed down, bounces off there, hits this point, comes back up, it crosses at this one. So the only thing I don't know is where it is right here. So that's my between and beyond. I need to plug in 1.5 and find out what it equals. So if I plug in 1.5 up here, working above the equation now, I get -1/2. 1.5 minus 2 is -1/2. 1.5 plus 1 is 2.5, which is the same thing as 5/2 squared. 1.5 minus 1 is a +1/2. So now I'm going to see what all that equals. Well, the negative times a negative is a positive. 2 times 2 is 4. This 2 is squared, so that's another 4. So that's 16 times 2. So that's 32. And on the top, going across, I have 25 because of the 5 squared. So what I can see is that this fraction is less than 1. It's not very big, so I just don't need to go up all that high. Again, I'm not trying to be a machine. So this is the sketch of that graph. But notice how important it was for me to catch that that multiplicity of 2 meant it just bounced at the x-axis right there. Okay, now the intermediate value theorem means that for any polynomial with real coefficients, when a and b aren't the same, if the polynomial's functional value at a and the polynomial's functional value at b have opposite signs, then the function has a real zero between those two numbers. So what is this in everyday speak? It means if you plug in two different numbers and one of your answers is positive and the other one is negative, then there had to be a zero in between there, because we don't pass from positive values to negatives unless we cross zero. So that is just the intermediate value theorem. I know that this sketch is a little bit blurry. I just copied and pasted that one out of the textbook because that was certainly more complicated than I could easily recreate. But it's just saying you get a positive number and you get a negative, there must be a zero in between them. So then to use the intermediate value theorem, what we want to do is plug in these two numbers and see if there's a zero in between them. Okay, so we're going to plug in f of -4 and f of -2. And you're just going to take -4 and plug it into that and see what it equals. Okay, so I'm going to take -4 and store that into x and hit enter. And now I'll be able to type x cubed plus x squared minus 6x, enter. And I got -24. Now we're going to do this exact same equation, you can see, with the -2. So I'm going to take -2 and store it into x, and then I can back up to where I've already typed it. So you can kind of copy and paste and hit enter again, and I got 8. Oh, I don't know why it's doing that, but got an 8. So since I got a negative value and then a positive value, is there a real zero in between them? Yes, according to the intermediate value, there is. All right, now these next two both have to do with that same equation, so yay, I don't have to retype all that. I can just store a new value into x. -1, store into x, enter. And then again, back up and copy and paste. And I got 6. So when I plugged this one in, I got 6. So now I want to take 3 and store it into x, and I got 18. These are both positive. The intermediate value theorem just says that there's a real zero. Now, let me point out something. This actually does not mean there is not a real zero. We just don't know that there is for sure, because it could hit the x-axis and bounce back in between those. But we just know it's positive at -1 and it's positive at 3. So it's above the x-axis, both of those places, so we don't know for a fact from the intermediate value theorem that there's a zero. Now both of these next two problems have the same sort of thing, but again, it's just applying that intermediate value theorem. We're going to plug in numbers. So I need to store -1/2 into x and then retype that in. Okay, so this one is 1/3 x to the 4th minus x cubed. And this one I got a decimal, but it was positive. And it's really not important what the answer is. You just want to know if one of the answers is positive and the other one's negative. So I've got to take 0.5 and store that into x. And that one came out to be negative. So since that one is negative and the other one was positive by the intermediate value theorem, yes, there's a zero in between. Now let's do it for 1 and 2, and that'll finish up this slide. That one's negative. Now I've got to take a 2, store it into x, and this one's negative. So no, we don't know for sure that there is. This is just a matching. It's this slide and then one more, so hang in here. We're going to just look at these, and this is a lot of the skills you'll have to use on your homework. What I know, a couple of quick things, and then we get more specific as we need to. It's negative and even. So both sides are headed down. And if I plug in a 0, this equals 5. So let's just see, both sides are headed down, and it has a y-intercept at 0, 5. Oh, no, here it is, 0, 5, right there, and both sides are headed down. That one's H. Okay, This is negative and even. Even means they're both going the same direction. Negative is they're headed down. We plug in a 0, we get -3. So we want the intercept to be at 0, -3, and both sides headed down. That answer is D. You can identify that. Positive, even, both sides headed up. Plug in a 0, and we end up with -4. So both sides headed up, and 0, -4. Right here. Now see, there's a lot of other stuff going on in the graphs, but when you're just having to match, you don't necessarily have to do all of it. You just do as much of it as you need to. So here this is negative and an odd power. So it is headed down on the right, up on the left. If you plug in a 0, you get 4. So two different directions, y-intercept at 0, 4. I'm just going to hold off on that one for just a second. This one's positive and odd. Positive and odd up on the right, down on the left. If you plug in a 0, you get 0. Oh, that's A right here. This one, positive, even. They're both headed up. If you plug in 0, you get 0. Both headed up, plug in, that one's C. I don't know why on number 4 I totally see it now. It is B. There's my intercept right there. It's because I was expecting that curve, but if I look at the full equation, this is just an mx plus b form, so that's just a straight line. Okay, positive, odd. Plug in a 0, you get 2. So you can see what the end pieces are doing, and you know where your intercept is. So that one is I. Negative, odd. Going different directions, down on the right. Plug in a 0, we get -1. And that one is E. Now, if you weren't sure, if some of them looked really close, then the next thing you do is find your X-intercepts. But you don't necessarily need to do that. You can also count how many different bends and curves there are, and you can just keep going through the process we did on the other couple of slides, but you don't necessarily need to do all of that. All right, so this one is positive, even, going up on both sides. Plug in a 0, you get 6. So up on both sides, and it's got a y-intercept of 6, it looks like. That's going to be G. It's just off the graph there, but you can see that that's where it would hit. We already used a J. This one, since it's the only one left, that makes it incredibly easy. It must be F, but since it just equals a number, then we know it's a horizontal line. All right, this last slide, this is a homework help. You have a homework problem. It's question number 9, just like this says here, and it looks just like this. I've had several students contact me before about this interactive tool and figure where they just got really confused. So here is my tip to you. Do not use the interactive figure. I know it says click to launch it, but you don't need it. You can use the intermediate value theorem. It's asking you if the function, and your function will have different numbers than this one probably, but it's asking you if the function has a 0 between 1 and 2. And you may have different numbers there. So the intermediate value theorem says we can plug in a 1 and we can plug in a 2. And if those both get the same sign, then we're going to say no, it's false. And if we get a positive and a negative, then it's true. So when I plug in a 1, I can just visually kind of look at this one and tell you the answer is going to be negative. Okay, and if I plug in a 2, that answer is going to be positive. So for this particular one, since it's a negative and a positive, is there a 0 in that interval? Yes, there is. Okay, so don't let that interactive figure mess you up.